Hello friends, welcome to my YouTube channel is Aviation. Here we discuss about the short simple topic about aviation field. Today's topic discussion is that what are the forces which are acting on an aerofoil. So first let's understand what does an aerofoils mean. So aerofoil is a kind of a shape of a body in which when a body passes through air, through a medium, it produces more of a lift force than the drag force. So this is actually not a very elementary class. I think you should be aware about aerofoil structure, lift and drag. We'll be going a little bit one step ahead, in which we'll be discussing about the different forces which will be acting on an aerofoil structure. So as you can see, there are three pictures. First is of a fixed wing aircraft, in which you can see this is the wing, which is a lift generating component of the aircraft, and also definitely the tail wing. So the structure of the wing is kind of an aerofoil. So as you can see here, similarly in the tail also. Second picture is of a Chinook aircraft, in which the main rotor blade of the Chinook of the blade is in an aerofoil structure. Similarly, this is an Sikorsky helicopter, and the tail rotor blade of the same is in an aerofoil structure if you clearly see it. So these are known as aerofoil structure, which when move through the medium, through the air, produces more of a lift force, generates lift force, and that's how the aircraft flies. So we'll be discussing about the different forces which acts on these of a airfoil structure. So let's draw an aerofoil first. So this is an aerofoil structure. So we'll be discuss a little bit about the symmetry, few main characteristics. So this is known as the leading edge. The tip of the aerofoil structure is known as a leading edge, and this is known as trailing edge, the last tip, the end. Okay, a straight line which is joining trailing edge and a leading edge is known as chord. Okay, and a line which divides the complete aerofoil structure into two equal parts, A and B, imaginary line which divides the complete aerofoil structure into two parts such that A is equal to B, is known as a camber, and this line was known as camber line. So a little Jan over it. Let's say there is an aerofoil 1 and aerofoil 2. So if we make a chord line, that means we'll join the trailing edge and a leading edge with a straight line in both the aerofoil 1 and 2, and then we draw a camber. So if we draw a camber in 1, says that this is equal to this, and if we draw a camber in figure 2. So if camber line is conjoining the chord line as we see in the 2, so these are known as symmetric aerofoil, and they are known as asymmetric. And if the camber line is above the chord line, as you can see in figure 1, so this is positive camber. And another case, let's say like this, in which if we make a chord line like this and a camber, and if the camber is below, this is known as negative camber. I hope you get the idea. So this is a basic knowledge about the aerofoil, trailing edge, leading edge, what is the chord line, what is the camber, what is the positive camber, negative camber, symmetric aerofoil and asymmetric aerofoil. So now we'll discuss about the different forces which are acting on the body. So I have made an aerofoil and a chord line. So this aerofoil which I have drawn is a positively cambered aerofoil. Asymmetric, definitely if it's a positively cambered. There is a leading edge, this is known as trailing edge, and this is a chord line which we have already discussed. And I have made a straight line. This is a airflow which is coming in. So I hope you are getting an idea. Basically this is actually a wing which I have shown you in the figure. This is a wing in case of fixed wing aircraft, or a blade in case of a rotary wing helicopter. You are aware about, I'm sure you are aware about this, which we are discussing. And then there is a airflow which is coming in, which this airflow is which I have represented here. Understood? Because of the curvature of this aerofoil, the air will tends to go downwards, is one of the reason, because of the curvature. Second is that there is a low pressure area at the top, and then there is a high pressure area at the bottom, which we had discussed multiple times, that why the aircraft fly in the air, because there is a low pressure area above the wing and the high pressure area at the bottom, and which generates the upward force, and that's how aircraft flies in the air. Correct? So because of this high pressure and low pressure, there is a leakage of air from the bottom to the top. Understood? And which further tends to make the airflow coming down. because of the high pressure and low pressure. I have made a separate video on the winglets and sharklets, which you have seen in the commercial plane. If you go through that video, you will get a more idea about this part which I am discussing. So these two are the reason which leads to another force which is downwards, which I'll draw here. So there is a downwash. We call it a downwash due to induced flow. I hope you are clear about this much, right? So if I do a vector summation, there is a straight line, so which is known as relative airflow. I hope this much is clear. This is a relative airflow, this is a downwash flow, this is a normal general airflow which is coming in, and the angle between the chord line and the relative airflow is known as angle of attack. So this is angle of attack. I hope this much is clear, correct? So I'll make another airfoil and I'll be drawing only the required parameters, required design parameters which is required. So this is a airfoil, this is a chord line, I'll write it here, chord line, this is leading edge, this is trailing edge, okay, and this is center. Okay. So this is the airflow, this is the relative airflow, and this is the downwash. I hope this much is clear, okay, and this is the angle of attack, correct? So if I bisect the complete figure into 4 quadrant, which I generally do to easy the drawing. So this is relative airflow. Any force which is acting perpendicular to the relative airflow is the lift force, and any force which is acting in the direction of the relative airflow is the drag force. Understood? And if we do the parallelogram summation which you might have learnt, so this is known as the resultant force. I hope this much is clear, correct? This resultant force can further be resolved into vertical component, resultant force vertical, and the resultant force in a horizontal. So this resultant force vertical and resultant force horizontal are required. This is required. This value is calculated is proportional to the weight of the aircraft, like how much weight is there for the vehicle, for the aircraft, and how much resultant force in the vertical direction is required to lift the vehicle or lift the aircraft, correct? And this resultant force horizontal is calculated in terms for like this much is the drag, this much is the force which is required to be overcome, and accordingly proportionality or accordingly engine is designed to produce the power or thrust which is required to overcome this resultant force horizontal. I hope this much is clear, and this is how the forces are calculated. So if you have any other queries regarding to this figure, this topic, please let me know, okay? And if you want to know any other topic in regarding to the aviation field, please do comment. I'll make subsequent videos considering your request. So please share the video to maximum aviation lovers, and thank you. Here I sign off. Thank you.